Okay, let's go on to question 3, homework exercise 3. This one we're looking at the question, which is cheaper, eating out or dining in. So the cost of a flank steak, broccoli, and rice bought at the grocery store is $13.04, and then a sample of 100 neighborhood restaurants showed a mean price of $12.75, and a standard deviation of $2 for a comparable restaurant meal. Okay, so on either side of that. A, develop an appropriate hypothesis for a test to determine whether the sample data support the conclusion that the mean cost of a restaurant meal is less than fixing a comparable meal at home. Okay, so that's your alternative hypothesis, that the average would be less than the cost of eating at home, right? So this null hypothesis that you're setting up here is that the mean would be greater than or equal to what you paid to eat at home. And if we set it up this way, then we can say that if this supports this and we can't reject the null hypothesis, then we can't make the statement. We can only say that there is not enough evidence that it's significantly cheaper, right? We can't accept or make a conclusion that it's cheaper. We just say we can't reject it, that it's cheaper. And then if we can reject, then we can say, yeah, it's the average price is less than that, less than $13.04. All right, so we set it up then that the mean that we're testing is $13.04. Sample size in this example is 100. 12.75 is the cost of the restaurant meal, $2 standard deviation around that. So it could be $14.75 roughly, right? We'll calculate confidence interval in a second. And then make sure this is good to go. So we got standard deviation divided by the square root of the sample size to get the standard error, which we need to have to run this t-stat. So this t-stat is going to give us a number of standard deviations away from the mean. So we have x minus u divided by SE. Okay. So this is within 1.96, right? It's within 1.96. So it's probably not going to be something we're going to reject because it's falling before that. But let's keep going and we'll prove that out. So this is equal t dot dist, and you grab, whoops, grab the t-stat you just did, degrees of freedom. So if it's a sample size of 100, subtract 1 from that, and then say true. This is 1 minus that, and this one is equal to 2 times the minimum of whichever one of these has the smallest. Okay. So because we've set it up to find out which one's cheaper, we're down in the lower tail. And because this is greater than like the tipping point, which is 0.05, so it's basically what we're saying then is above that in terms of the graph. So if you plot the normal distribution, 0.05 is to the left of this value, right? So we're not into the tail, in other words. So if it's greater than that level of significance, we say do not reject, you're within that zone, okay? And so we'd say, because remember, we're not accepting anything, we say we cannot conclude that the cost of a restaurant meal is significantly cheaper. Okay, so we can't make that determination just based on this average price, okay? Given the sample size and whatnot. Let's do this confidence interval. So that's equal t dot inv dot 2t. And we got 0.05. And we got 99. Take that times standard error. And then you can take x and subtract that. And you can take x. Okay, so you notice that that 13.04 is within that range, right? So it's within that range. There we go. All right, so that means do not reject, right? So they're not, the average data point is not outside the range of possibilities that could fall in. So what we're saying here is that the sample that we took isn't strong enough out in terms of its average, and in terms of the standard deviation, there's more volatility there than is warranted for us to draw the conclusion that this null hypothesis can be rejected. Okay, so let me go on to the next one and see if we can wrap this one up too, and then I'll have one more video. Okay, so this is a national mean annual salary for a school administrator is $90,000 a year, so that's right here. If school official took a sample of 25 school administrators in the state of Ohio to learn about salaries in that state to see if they differed from the national average. So here they all are there, it's not that many. There's a few in this column. Formulate hypotheses that can be used to determine whether the population mean annual administrator salary in Ohio differs from the national mean of 90,000. So we're going to do that right here. So we would say HO, the null hypothesis, is that U is equal to 90,000. Okay, and the alternative is that, alternative is that U does not equal 90,000. So it could be more or less than that, right? So we don't want to get into the tail. It could be more or less than that. So if we take the average of that sample that's sitting over there, and we also do standard deviation S. Try that again. Well, goodness me. Okay. Highlight that area again. There we go. And the standard error is going to be S divided by the square root of the sample size. Okay. So now the t-stat is going to equal X minus U. So X, the mean here, minus U is over here. And then divide that by SE. So you're getting the difference spread out over the variation, right? So that is greater than 1.96, right? So it's going to be on the outside of it. So I think you're probably going to be able to reject here. Let's do the p-values. Equals t.dist, grab your t-stat, get your degrees of freedom, which is going to be 24, so 25 minus 1, and true. Okay, then equals 1 minus that to get the upper tail, and then equals 2 times min of these two to get the 2 upper tails. So because we could have been on either side of this, right? U does not equal H, equal 90,000. So it could have been more than that, or it could have been less than that. So you need two-tailed test. And so in this case, we'd say that that is less than 0.05 significance level, so we reject. Right. The mean in Ohio significantly differs from national average. Okay, and it was 85,000, which is quite a bit less than this, but this is telling us that yes, that's a statistically significant difference in the value. And we can do the confidence interval, just having you do all these things a bunch of times so that you get good at it. Probability is 0.05, degree of freedom is 25 minus 1, or 24. Okay, and then you take that times the standard error. And then you take X and subtract that. And then you take X and you add that. Okay, and you notice that the 90,000 is not in that range. Okay, so the Ohio salary you can draw the conclusion that 90,000 is not in the range of possibilities that you would expect to see 95% of the time. It's very close, but it's not in that range. Okay, I'll stop sharing that, and then we'll have one more video for the last one.